Thank you, Johannes. So I'll start without further ado the session on sustainable control. We have a keynote coming up and then a series of talks around various aspects of complementary and alternative control, including plant-based approaches, biological control, grazing, and vaccination, following in the same way as working groups 1 and 2, following that with a moderated discussion. I'm going to start with a few slides of introduction from myself and from Hervé Host, co-leader of Working Group 2. I just want to remind you about Mentimeter. The code is in the chat box for this session. It's 1142113, and you'll be asked 3 questions, and then you'll be able to enter your own questions for the presenters. And in between presenters and during the panel discussion, then the chair will be able to read those out. Again, we won't be able to cover all of them, of course, but we will do our best. So Working Group 3 is indeed challenging. It deals with the objective of developing practical and sustainable helminth control strategies, integrating insights from the diagnostics, targeted treatment and targeted selective treatment approaches, epidemiology, vaccinology, and the farm economics and farmer behavior. So it's a big challenge, but we don't aim to completely reinvent this field. We just want to take some of the insights from the other working groups and from our own efforts into a more integrated view of helminth control on farms now and in future. And Hervé Host is co-leader of this working group, and Samaro is kindly helping us to co-chair today. We break down the aims of Working Group 3. Some is database driven to try to collate information on these alternative control approaches, and importantly, the evidence for their usefulness, but also around the variation in their usefulness, and to start to broaden the concepts towards how we integrate these different control approaches in an effective manner, especially in livestock systems in Europe. Evaluating impacts of future changes, importantly, we'll use in silico approaches and epidemiological modeling, and we're well advanced with these 3 tasks in green. So last month, for example, we held an online training school, was very well attended, around the principles and practice of modeling parasite transmission under climate change, with a specific intention of bringing empirical based researchers into the sphere where they can start to explore the usefulness of their new control approaches in this context and not rely only on specialist modelers to do so. The further tasks we will be focusing more on in the next year, many of you are already involved and some others will become involved, to conduct gap analysis of decision support tools and the needs for them, and to report on best practice guidelines. But recently we've been discussing more, should this be a basket of options that is suitable in different circumstances rather than a more narrow best practice set of guidelines. So in a couple of slides, I just want to revisit why current control is not sustainable. And I think it's clear, if you're here, you know already, the whole action is about anthelmintic resistance. We cannot ignore it, it's growing. It poses an existential threat, especially grass-based livestock production worldwide, and no less so in Europe. But there are other reasons. For example, even within the production cycle, excessive reliance on anthelmintics can interfere with the development of immunity, and excessive reliance on anthelmintics also has promoted genetic selection of breeds that are not very resistant or resilient. These other reasons, though, climate change, environmental impacts, food residues, they've always been considered, but in the past they've been considered as an add-on, as a mention after these main reasons for lack of sustainability. And actually their importance is growing and they are more complex. So climate change, for example, might increase infection pressure, but it will change seasonality and predictability of infections in different ways, in different places, and increase between year variation in epidemiology. Environmental impacts, again, we have more than one direction here, so maybe effective anti-helminth control, or effective helminth control has a very important role to play in limiting greenhouse gas emissions from livestock, but at the same time, the tools that we use to control these helminths could have their own environmental impacts, notably, for example, on the effects of anthelmintics on invertebrate fauna, and also in environmental manipulations such as drainage. Many of these must be viewed through a prism of regulation and consumer choice, and that means we have to integrate this with other considerations like land use, policy priorities, and animal welfare. So we must move towards a much more holistic consideration of parasite control. What is clear is that we cannot any longer rely on anthelmintics as the first and the last choice when we come to consider parasite control. For sure, they will continue to play a role. So this was one of our first outputs from Working Group 3, a paper led by Joseph Cruza, who's here with us today, trying to reimagine a future where we don't use anthelmintics in the same way. We use them as therapeutic interventions rather than preventive control. It's very difficult to imagine such a world. This is where we are going, though. Fortunately, we have viable alternatives, such as vaccines, biological control, nutraceutical forages, breeding resistant livestock, and grazing management. Intensive research in these areas, and many of you are involved in that research, which is making inroads. What is clear is that these are all partial solutions. None of them will completely replace anthelmintics as a standalone single control approach. And so maybe rather than alternatives, they should be considered complementary to each other, or complementary to anthelmintics. This raises difficult questions around how to consider and test the best combinations. If we can't use a single one of these only, then we have to be mindful that they might interact. They might interact directly. For example, diet affects anthelmintic absorption. They might interact indirectly and around the farming system and around the climate. So these would be very specific interactions in different contexts. And again, in silico approaches such as epidemiological modeling can explore those interactions and can start to design and support efficient field trials where we don't have to only rely on very expensive and difficult trials replicated across years and across locations to at least start to build better integrated approaches to control. The second point is that where we are bringing in other complementary control approaches into a system that is very much evolved for setting standards and testing effectiveness of chemical anthelmintics, we come against the problem of how do we standardize or set standards at least for the effectiveness of these different control approaches. And this is where I'd invite Hervé to say a few words.
So as Eric mentioned, one of the challenge currently for this WG3 is also to analyze the gaps to implement this solution, alternative solution on the field and in farm conditions, and also to try to define better a range of basket of options. And basically, the idea is that pharmaceutical companies, besides providing a range of very efficient molecules, at least before the rise of anthelmintic resistance, they have also provided a grid to evaluate these commercial anthelmintics. So it's a sort of frame of reflection and grid of criteria to evaluate both the scientific issues and the research and development issues. And the idea with Eric is to evaluate whether this grid can be applied also on alternative solutions. This grid being basically a sort of reference and model for scientists, but also for farmers, probably. Next slide. So this is just a detailed description of the different criteria which are taken into account in this evaluation for synthetic anthelmintics. On the left, you've got the scientific issues with the quality of the product, efficiency and multivalence against different worm, what is called broad spectrum anthelmintics, knowledge on the mechanism of action, food safety and safety for the animals. And on the right, different conditions to increase and improve the implementation on farms with very well-defined conditions of applications and what is taken into account to facilitate the application on farm in regard of the farmer point of view. And of course, regulation bodies are very important to consider. Next slide, please, Eric. So basically, this is again a description of the different solutions which are classified according to different target. Some solutions which can be used in alternative control are related to an effect on the parasitic worm populations, modulating the biology of the worms, A second set is the possibility to improve the host response. And the third set is to try to limit the contact between the animals and the free living stage with different solutions which have been exposed previously by Eric. And of course, as underlined, this should be integrated and this should rely on a combination of the different solutions with the help of modelization. We think we can arrive with this sort of grid of analysis to identify the gaps and to identify also different basket of options within a time frame. Thank you, Eric.